Okay, this video will explain how we do problems that have projectiles that are launched at an angle. There are basically three different kinds. One that's ground to ground, so our dy is equal to 0. So let's go ahead and talk about how we label projectiles at an angle. This would be our dx, and since there's no change here, that's why my dy is 0. For number 2, when you go from a hill, for instance, to the ground, that dy becomes negative. Here's my dy again, here's my dx. For the third one, going from ground to hill, the dy is positive. So just keep those in mind. The change in your vertical distance depending on if it's ground to ground, hill to ground, or ground to hill. So if we take a look though, since it's launched at an angle, we have something that's unique to projectiles at an angle versus our horizontal, because now we end up having a vertical velocity. So if something's launched at, for instance, 25 degrees, we do have a Vx and we have a Vy. We know horizontally speaking we still have that constant velocity. So a question could be, where will the marble land if launched at 25-degree angle with a launch speed of 5.9 meters per second? So what we'll do is at launch speed, and that's what we have just determined using our launcher, we'll put that as our hypotenuse. So if we go ahead and take a look at our XY chart, what we'll still see is that this is 0 meters per second squared horizontally. Our vertical acceleration is due to gravity, negative 9.8 meters per second squared. So now what we have to do is figure out the rest. Basically, our Vy is no longer 0 like it used to be. We have to go ahead and determine that, and guess what? We have trigonometry again. So we have opposite over hypotenuse, which will equal our 2.49. So 2.49 is going to be our vertical velocity. To come up with our horizontal velocity, we need to take the cosine over 5.9, and that comes up to be 5.35. Make sure your calculator is in degrees and not radians. And so I go ahead and put that over here.